Hi students, this is AJ sir. Let's study 9th standard ICSE Math, chapter 1C and 1D.
Exercise 1C, question 1. State with reason which of the following are surds and which are not. Now, surd is, simply speaking, any number which has this umbrella on it. That is a root sign, a square root sign, or a cube root or a fifth root, which cannot disappear. All surds are irrational, but all irrational numbers are not surds. For example, pi is not a surd, even though it's irrational. Now, root 180 has an umbrella, but we'll have to solve it further to ascertain if it is a surd or not. So, first we find the prime factors of 180. So we see that we do have groups of 2, that is pairs of a few numbers. So under the square root sign, since I have two 2's, bring it out and write it only once. I have two 3's, so bring it out of the umbrella and write it only once. But 5 is alone, so it cannot come out. So that will remain under the umbrella. So the simplified version of root 180 is 6 root 5, which is a surd because I still see the umbrella, that is a root sign. The next question is fifth root of 128. So again, let's do the prime factorization. I see that there are 7 2's, but since it's a fifth root, a group of 5 can come out. And we'll write it once outside, but these two 2's will remain under the umbrella. So the final answer is 2 into fifth root of 4. We can't simplify it further. There is still an umbrella, hence it is a surd. Now in Roman number 5, it's cube root of 25 multiplied by cube root of 40. Since both of them have a cube root, we can bring them together and they can share a common umbrella, so multiplication is possible. Now prime factorize it, we see that we have 3 5's and 3 2's, so we can bring them out of the umbrella. 5 into 2 is 10, there is no umbrella left, hence it is not a surd. Roman number 8, root of 3 plus root 2. Now in a surd, under the umbrella, we should have rational numbers. But root 2 is irrational. It itself is a surd. So whenever you see a root under another root, which cannot be simplified further, it is a totally an irrational number, but it is not a surd. Because in a surd, under the root, there should be a rational number. So this is not a surd. Next, write the lowest rationalizing factor of root 24. Which means, with what should I multiply this to make it a rational number? So what we do first is, we remove the prime factors. Here I see that there is one group of 2 2's, so take it out. But this 2 and 3 remain alone under the umbrella. So the simplified version is 2 root 6. So the lowest rationalizing factor will be root 6, which means that if I multiply this with root 6, it becomes a rational number. See, what happens here is 2 will remain as it is, and root 6 into root 6 is 6. So that will become 12, which is a rational number. Yes, we could have multiplied root 24 with root 24 directly to make it a rational number, which would be 24. But they have asked for the lowest rationalizing factor. So the answer is not root 24, it is root 6. But why would we want to multiply it with a rationalizing factor and make it a rational number? Well, that is for some future sums, which we'll study shortly. Now for Roman number 4, the question is 7 minus root 7. It's a binomial term. This was a monomial, but this is a binomial expression. So here the lowest rationalizing factor is the conjugate of this. Conjugate means the same expression with an opposite sign. So the answer is directly 7 plus root 7, which means that if I multiply this with this, I will get a rational number. Let me show you how. So if I multiply the two brackets, this is of the form a plus b, a minus b. And that formula is a squared minus b squared. That's 49 minus, what is root 7 squared? 7. Final answer is 42, which is a rational number. So you can see how we can convert this irrational binomial into a rational number by multiplying it with its conjugate. What is the use of this? Again, we will be using these methods in the future sums. So the 6th and the 8th sub-questions are also binomial expressions. We can't simplify this any further. But we can remove 3 common out here. So whenever you can remove anything common, we should. So the 6th answer is simply root 5 plus root 2, the conjugate. Because if we multiply these two brackets, we will get a rational number. Now here, the first thing we should do is take out 3 common. So what is left in the bracket is 5 minus root 2. So the lowest rationalizing factor answer is 5 plus root 2, the conjugate of this bracket, which means if we multiply this with this, the final answer will be rational. Now when you write the answer, please don't write equal to sign, because this is not equal to this. It's just the answer for this. Now we start with the important sums of this chapter. Rationalize the denominators. Here in the fractions we see that we have root signs in the denominator. But in any sum, we should never keep the root signs in the denominator. That's not the standard form of writing math. We must rationalize the denominator. So how do we do that? Well, we multiply with the rationalizing factor. In this case, it is root 5. So multiply numerator and denominator both by root 5. The numerator changes, of course, which is fine. It becomes 2 root 15, which cannot be simplified further. But the denominator becomes root 5 into root 5, 5. So see, the denominator is now a rational number. So this is a standard form. And this is the final answer for this question. Now in this question, the denominator has a binomial. So we'll have to rationalize it by multiplying it with its conjugate, that is with the opposite sign. And of course we should multiply the numerator and denominator both. Now we will not open the brackets in the numerator, but the denominator is of the format a plus b, a minus b. So we'll use the formula a square minus b squared, which makes it a rational number. In fact, we can even reduce it, 3 and 3 cut. So what we are left with is just the numerator, which is irrational, and that's fine. The denominator, at least, which is 1 in this case, is not irrational. Now in Roman number 6, again we have to rationalize this denominator. Interesting sum here, because when we use the binomial of the denominator, that is opposite sign, we see that that was same as the numerator. So the numerator becomes root 3 plus 1 the whole squared, because it's the same bracket twice. But in the denominator it is a minus b and a plus b. So the formula is a squared minus b squared. Now let's use the formulae. The numerator was a plus b the whole squared, so it's a square plus b squared plus 2ab. And the denominator obviously will become a rational number. Solving further, we get 3 plus 1 plus 2 root 3 upon 2. Now we can take 2 common out. So take it out, the remainder in the brackets, 2 and 2 get reduced. What is left is this, is the final answer. Now remember, while rationalizing, make sure you put brackets. That is very important. Now in the 8th sum, this is what is given. So once again, brackets, rationalizing factor is just the conjugate of the denominator, not conjugate of numerator, only denominator. The multiplication up and down should be with the same brackets. So the denominator becomes a plus b, a minus b, that's a square minus b square. And the numerator brackets, interestingly, are same. So it's root 6 minus root 5 the whole squared. Apply the formula. A minus b the whole squared is a squared plus b squared minus 2ab. Denominator becomes 1. That's good. It's rationalized now. And what happens in numerator? Well, root 6 into root 5 is root 30. That cannot be simplified further. And this is the final answer. Now in 4.2, we have been given this equation, and by comparing we have to find the values of a and b. But here we should convert it into this format, then only we can compare. And for that we simply have to rationalize the denominator. So we multiply with the conjugate, the denominator, and the numerator becomes a minus b the whole squared. Denominator will use a square minus b square formula. The numerator is a squared plus b squared minus 2ab upon 7 minus 4. Solve further and we reach the final answer, 11 minus 4 root 7 upon 3. But to convert this into this form, see that root 7 was in the first term here. So we'll have to write this in the beginning. Minus 4 root 7 will be in the beginning and plus 11 will be the second term. And also we have a common denominator, so just let's split it into 2 fractions. So it becomes minus 4 root 7 upon 3 plus 11 upon 3. Now this is of the format a root 7 plus b. So now we can compare it. So here a will be equal to minus 4 upon 3 because root 7 is same. And b will be equal to plus 11 upon 3. So that's your final answer. Now in Roman number 4, again it's a similar type of sum. So let's convert this into this format by rationalizing it. And to rationalize it, we shall multiply the denominator with its conjugate, opposite sign, and the same bracket should be used in the numerator as well. So this becomes a plus b the whole squared, and the denominator is a squared minus b squared. Now use the formula. A plus b the whole squared is a squared, that is 25, plus b squared plus 2ab. And the denominator is 25, a squared, and the b squared is, well, 3 squared is 9 and root 2 squared is 2, and there is a multiplication between them. So it will be 9 into 2, which is 18. So even out here, let me write this as 18. This becomes 30 root 2, and 25 minus 18 is 7. So adding this, we get this. Can I simplify this further? Can I take anything common? Nothing. Always check all these things. But now let's split them into 2 fractions so that it is easy for me to compare. A is 43 upon 7 and b is 30 upon 7 because both of them have root 2 signs. So that's your final answer. Now question 5.2 is simplify. Mark 5.2 as IMP. Also mark 3.9 as IMP and the 12th sum as IMP. Now in 5.2 we've got two fractions given. Now either you can first take this fraction, rationalize it, then take this fraction, rationalize it separately, and then subtract the answers, or solve it together, which I have done here. So on one hand I'm rationalizing one fraction minus the second fraction and I'm rationalizing that. Don't think of it as cross multiplication or LCM or anything. This is simply rationalizing the respective denominators. It is interesting that by doing it, the denominators will automatically become equal. Now let's focus on the numerator here. We'll have to do distributive multiplication. Root 2 into root 6 is root 12. Root 2 into root 2 is 2. Now minus sign I write here. Root 3 into root 6 is root 18. Root 3 into root 2 is root 6. And the denominators become a squared minus b squared. Now root 12 can be simplified. If you do the prime factorization, it's 2 into 2 into 3. So I got two 2's out here. So I can remove 1 2. So this becomes 2 root 3. It's like this. Root 12 is 2 into 2 into 3. Take 2 out. So that's 2 root 3. Similarly, root 18 is 3 into 3 into 2. So 3 can come out, but 2 can't. So this becomes 3 root 2. Root 6 cannot be simplified further because it's 2 into 3. They are just single numbers, 2 and 3. There are no pairs, so I can't take it out. The denominator has become rational, which is what we wanted. And the denominators are same, 4. So we can take the numerators together. But don't forget the brackets because there is a minus sign outside. So this inside sign will change. Now can we cut something or take something common or add or subtract anything? No, they are all unlike terms. So this is the final answer. Now the sixth sum has two values being given, x value and y value. And we have to find 4 parts. Let's find x squared and y squared. But don't just square the whole thing. Since the numbers are irrational in the denominator as well, first we should rationalize the denominator. So just the usual method, we rationalize the denominator for x by multiplying with its conjugate, which is root 5 minus 2. And here also we rationalize the denominator. It's a coincidence that these two numbers are conjugates of each other. Anyway, solve them separately. You can even solve them one below the other. So the numerator becomes a minus b the whole squared and the denominator is a squared minus b squared. Apply the respective formulae and we get the final answer as 9 minus 4 root 5. Similarly, we get the formula here as 9 plus 4 root 5. So now that we have rationalized the denominator, in fact the denominator has disappeared because it's 1, it becomes easy to solve. So Roman number 1 is find x squared. So let's square this value. A minus b the whole squared is a squared plus b squared minus 2ab. This is 81. B squared, well that's 4 squared is 16 and root 5 squared is 5. So this will become 16 into 5, 80. Minus 2ab, just multiply them, we get 72 root 5. So the final answer for x squared is this, and similarly the final answer for y squared will be this. Now in Roman number 3 they've asked for the multiplication of x and y. So we have the values of x and y, we'll multiply them. This is of the format a minus b, a plus b. So it should be a squared minus b squared, which gives us 1. And in Roman number 4, we have to add the three values which we just found out. X squared value we found out, y squared as well, and even xy. Now let's add them. Minus 72 root 5 and plus 72 root 5 gets cancelled. So 161 plus 161 plus 1 is 323. That's the final answer. Now in question 8, x's value is given and we have to find these three Roman numbers. First, let's find 1 upon x. 1 upon x is the reciprocal of this. We cannot leave a denominator with root sign, so we'll have to rationalize the denominator by multiplying with the conjugate up and down. So the numerator has changed, that's okay. The denominator has now become a squared minus b squared, which is a 2 square is 4 and root 3 squared is 3, so 4 into 3 is 12. Similarly, 2 root 2 squared is 8. In the numerator, I can remove 2 out common. By doing this, I'm able to cut the numerator and denominator and simplify it further, which should always be done. And this is the final answer for Roman number 1. Now in Roman number 2, they've asked us to find x plus 1 upon x. X's value was given. 1 upon x we found out. Let's add them. Well, here we have denominator 2, so we'll have to do LCM, so that we can get the numerators together and they can have a common denominator. Open the brackets, distributive multiplication. Now let's get the like terms together. What is 4 root 3 plus root 3? It is 5 root 3. It's like, what is 4a plus a? 5a. Similarly, 4 root 2 minus root 2 will give you 3 root 2. So this is the final answer. We cannot add them, of course, because they are unlike terms. If this is root 3 and this is root 2, we cannot simplify it further. Now in Roman number 3, they've asked us to find the square of this value. So we take this value and apply the formula of a plus b the whole squared. That is a squared plus b squared plus 2ab, and the denominator is also squared here. So this will be 5 squared is 25 into root 3 is 3, so that's 25 into 3. This will be 9 into 2, and this will be 30 root 6. And then multiply and add. There is no further simplification which can be done. Nothing can be taken out common. So this is the final answer. Now, in the 10th sum, the value of x is given and we have to find x squared plus 1 upon x squared. There is one direct method where we can use the formula x squared plus 1 upon x squared is equal to x plus 1 upon x the whole squared minus 2. But I'm going to do a longer method because I prefer that. So I'll find the value of x squared first, then I'll find the value of 1 upon x squared, and then I'll simply add them. Let's start with x squared. That is just squaring both the sides. Use a formula of a square minus b square minus 2ab and solve further to get this answer. Then we do the reciprocal of x and we rationalize the denominator to get the rational answer 5 plus 2 root 6, which interestingly is the conjugate of x. And then we square both the sides, so we get the value of 1 upon x squared. Again we use the formula a squared plus b squared plus 2ab. So we got the value of x squared and we got the value of 1 upon x squared. Now we add them. 20 roots minus 20 root 6 and plus 20 root 6 gets cancelled. So the final answer is simply 98. Now the 12th sum is very unique because for the first time we have a trinomial in the denominator. We know how to conjugate a binomial, but how to deal with a trinomial? Now check this out. Here we'll put the root 3 minus root 2 in one brackets, the irrational terms, and we'll consider 1 as the second term. So now we can think of it like a binomial, a plus b. So we'll multiply it with its conjugate, which is a minus b. Remember, this sign will not change. It will remain as minus itself because that's inside the bracket. Only this outside sign should be opposite, which is called the conjugate. And we'll multiply the conjugate in the numerator as well. So this is the first time we are trying to rationalize the denominator. So the denominator becomes a squared minus b squared. Now use the formula. So that becomes a minus b the whole square is a squared plus b squared minus 2ab. I'm writing the answers directly because by now you should be an expert in this. Minus 1, of course. Now this becomes 5 minus 1, 4. Now we can remove 2 common, so let's do that. If you don't do that, it's fine. You can now again use the conjugate of 4 plus 2 root 6, but I prefer simplifying it. So I'm removing 2 common. So now the conjugate to rationalize it is 2 plus root 6, and of course the numerator also has to be multiplied with it. So now the denominator becomes a minus b, a plus b, which is a squared minus b squared. But the numerator will be challenging now. We've got 2 brackets, so we have to do distributive multiplication. First term into the bracket minus second term into the bracket minus third term into the bracket. This is called distributive multiplication. Now the denominator becomes a squared minus b squared, that is 4 minus 6. And in numerator, again open the brackets, again distributive multiplication. So you see this sum is long because we are rationalizing the denominator twice. Once here and once here. Because we had a trinomial in the denominator. Now root 3 into 2, 2 root 3. Root 3 into root 6, root 18. This will become minus 2 root 2. Minus into plus minus root 12. Minus 2. Minus into plus minus root 6. And the denominator has become simpler, which is minus 4. Now in numerator, again simplify root 18, it becomes 3 root 2. We've done this in the past. Root 12 becomes minus 2 root 3. Now 2 root 3 and minus 2 root 3 get cancelled. 3 root 2 minus 2 root 2 is just root 2. It's like 3a minus 2a is a. Minus 2 minus root 6 remain as it is. And this is the denominator. But we should write the answer in the standard form. In the standard form, I don't want minus in the denominator. Shift the minus up. By doing this, all the signs change. It is actually nothing but into minus 1 into minus 1. If you go to see. So all the signs change. But again, I cannot have a negative term in the beginning. So just shift it towards the end. So now this is the final answer. Now in 13.2, they've given this fraction. So let's rationalize it. The denominator multiplied with the conjugate. The denominator becomes a squared minus b squared. That's 9 minus 2 squared is 4 and root 2 squared is 2. 9 minus 8 is 1. So the denominator disappears. So only the numerator is left, which is 3 minus 2 root 2. Now in this sum, the value of root 2 and root 3 is given. So we need to substitute these values if it is remaining in the final answer. So root 2 is 1.4. After substituting it, we get the final answer as 0.2. Now the 14th sum, we have to add this. Final sum. Phew. I'm sure you're heaving a sigh of relief. Well, here there are 2 terms, so either you can rationalize them separately and then add them, or solve it together, which is what I'm going to do. I will rationalize the respective denominators. Remember, this is not an LCM or cross multiplication, is just rationalizing the denominator. Focus on the denominator here. There's a plus sign here, so minus minus. There is a minus sign here, so plus plus. Now the denominators becomes the same. So let's bring the numerators together. Denominator becomes a squared minus b squared. numerator is a minus b the whole squared, expand it, and this is a plus b the whole squared, expand it. Solve further. My 8 root 5 minus 8 root 5 and plus 8 root 5 gets cancelled. Only the integers are left behind. Add them and convert it into a mixed fraction always.